Hello, students, and welcome to 5.6 that we're going to be looking at here today. So some of this will be a little bit out of order, but um, not completely. Just going to kind of front load some of the information to get familiar with all the types of triangles and kind of how they're going to react with each other before we do all of our congruency theorems, which we're going to start seeing in just a couple days. So here today, we kind of referenced it a little bit yesterday. But today, just looking at naming these things now based on their sides. So the first one, when all three sides are different lengths, that's going to be a scalene triangle. That's what we're going to call that. Excuse me. There's nothing fancy about that. Um, Nothing specific about that type of triangle. Pretty much just that the angles still add up to 180 degrees. Nothing special with that type. Now, the next type here that we're going to look at, this is an isosceles triangle. That is when the two sides that we're going to call legs, and we're going to talk about that on the next slide here in a second, the two legs are congruent. Okay, so those are the same length, and what that creates for us is those two base angles are congruent. So we're going to talk a little bit about that on the next slide as well, with some of those terms. And then that last one, referenced this a little bit yesterday, this is an equilateral triangle. Now, an equilateral triangle is a special type of an isosceles triangle. They could be, if you have an equilateral triangle, it's also an isosceles, kind of like how a square is a rectangle. It's just that special case of a rectangle. So an isosceles triangle, not only are the legs congruent, but all three sides are congruent. Okay, so all sides congruent, and then as well, you're going to end up with all angles congruent. Okay, so most of what we're going to talk about today revolves around the isosceles triangle. So let's kind of talk a little bit more just to be able to get those references and some of those vocab terms down. So sides, we call them the legs of an isosceles triangle. Okay, and they are congruent. Those are those two sides. They're the two sides that are congruent. So the legs are the two sides that are congruent. You can kind of talk about them in either direction. And then when we talk about the base of an isosceles triangle, that's that one side that's not congruent. Okay, but then that term base is kind of what gives us this expression, the base angles. So when we're talking about the angles of an isosceles triangle, the base angles are what's going to be congruent, where that base is that side that is not the same as the other two, and the vertex angle of an isosceles is where the two legs meet. Okay, so some of the problems that you're going to be seeing here today are going to start looking like this, where you'll be given some sort of information, whether it be measurements or congruency marks. You'll be given some sort of information that you'll be able to work from as far as where do we have congruencies, what can we assume, what do we know. So right now in this first one, they're telling you that JK and KL are both 13. So we know they're congruent. That creates an isosceles triangle, which then in turn tells us, well, if those two legs are congruent, then the base angles off of those legs, okay, because those base angles where the leg meets the base, those two angles are going to be congruent. So since this angle over here is going to be 35, we know that the angle that is now congruent to it is also 35 degrees. And on problem B here on the right-hand side, they're only giving you one side, but they're saying, hey, these little congruency marks for angles, all three of those are congruent. So that's how we mark angles congruent, is with that little arc in there. If you get an angle that is not congruent, it either just wouldn't have that symbol at all, or you'll see with more than one arc around it, that means that's a different angle measure or a different set of congruent angles. Okay, so the fact that they've all got that same congruency mark means they're all the same, which at first glance, well, hey, they're looking for a side length. Well, remember, when you have all three angles the same, that's telling you you have an equilateral triangle, which then you can go ahead and say all three sides are the same. So all three sides are of length 9. Okay, now looking at this next example, one of the mistakes that you're probably going to make right away is you're thinking, oh, if these two are congruent, and this also has a congruency mark, all three of those are congruent, which means all these angles are congruent, and x is going to be 65. Not the case. Slow down a little bit here. You can have congruent side lengths, but if they're meeting at different angle measures, they're going to create a different angle within that vertex angle, and then the two base angles will be different as well. So let's slow down here. Let's focus on what we know the most about. We know the most about this triangle right here. Okay? Since those two sides are congruent, we're only looking at that green triangle right now, then I know these two base angles where the congruent legs meet that base. I know that those two are going to be congruent. So if this angle that I'm given is 65, then this one is going to be 65. But I don't know anything about this yet, so slow down. Okay? Now, just go one piece at a time. Remember, we kind of have to walk kind of a crooked path sometimes. What do we know? What can we go ahead and assume with what we do know? Well, right now you've got 65 in each of those corners. So still, we're just looking at the green triangle right now. All that we can go ahead and say for sure at this point, 65 plus 65 is going to give you 130 degrees. So all you can say for sure is that this angle right here, that vertex angle in the green triangle, is going to be 180 minus 130, which is going to give you 50 degrees. That's all we can say for sure right now, is that one's going to be 50. Well, once you completely have that triangle figured out, knowing that angle down in the bottom left corner, knowing that vertex angle, what that's going to do for you is, I kind of covered it up, but I'm redrawing it back on there. They're telling you that that corner is a 90-degree angle. So if this green triangle has already taken up 50 of it, that means the rest of that angle into our second triangle, which now we're getting close to that answer, is going to be 40. So since that vertex angle takes up 40, and these congruency marks tell you that these two sides are the same, meaning it's an isosceles triangle, then these two angles, notice how I'm using a second congruency mark. Now those two angles are congruent to each other. It doesn't necessarily have anything to do with the 65 in the green triangle. So 180 degrees in this triangle minus the 40 degrees that are taken up by this vertex angle leaves me with 140 degrees. 140 degrees to split evenly between these two congruent angles divided by 2 will give me 70 degrees for each of these. So your x is 70. Okay, so that's kind of what we talked about, where you have to kind of walk through a path here. You're given this information and you had to get to this information. Well, let's think about the path we took. First, we had to go figure that angle out with our isosceles information. Then we had to go figure this angle out with knowing that the sum is 180. Then angle subtraction to figure out what this corner was. That was step 3. And then finally step 4 was being able to divide the remaining angle amount into those two congruent angles. Okay. And then lastly, I'm just going to set these both up here so these videos don't get too long. You guys have time to work. The two different types of problems you'll see with these two. Suppose that triangle DEF is isosceles, so they're giving you this information that those two sides are the same. Again, with the fact that we have an isosceles, then these two base angles are the same. The base angles that are where the legs meet the base. Suppose also that measure of angle E equals 5x plus 17, measure of angle D equals 2x plus 44. Find the degree measure of each angle in the triangle. Well, they're giving you these algebraic expressions. You need to set them up into an equation like we've done with some other situations this year. Again, they're telling you they're isosceles, that this is an isosceles triangle. We can then go ahead and say that, okay, then I know these two base angles are going to be congruent, which means my equation is going to be set up for those two equaling each other. 5x plus 17 equals 2x plus 44. Again, to save time, I'm not going to finish that, but you would go ahead and solve for x and make sure you're answering the question that they asked. Find the degree measure. Once you have x, you plug it in to find these two angles, and whatever's left over will be that vertex angle. Okay? Sorry. And then going down to the other type of problem that you're going to see here, very similar, but they're not giving you the two base angles at this point. So what they're saying this time around, again, suppose it's isosceles, okay, then I know these two angles are congruent. And then they give you your expressions. Well, right now, these two angles at Q and at P are not congruent, so you can't go ahead and make the equation equal to each other like we did up top. Well, what do we know? Well, if the angle at P and the angle at R are congruent, I can express R with that exact same expression. I can say R is also 4x minus 10. Now, setting those two equal to each other won't do anything for you because they're the exact same expression. You'll just have them ending up zeroing out. But what you can go ahead and do is that all three of these are going to add up to 180. So whether you say that as 2 times 4x minus 10 plus 2x plus 60 equals 180, or if you write it all out right away and just say 4x minus 10 plus 4x minus 10 plus 2x plus 60 equals 180. Either way, either one of those is going to work for your equation to set this up. Again, you're going to solve for x. Make sure you're answering the question that they're asking. You're finding the degree measures. So once you have x, you'll plug x in, get the actual degrees. Okay? I hope this helps you all get started. Your assignment is on Alex. You got a couple problems that are just like each of these. And it looks like we did a really good job yesterday. I was checking out Alex as the day went. So good job. Keep working and have a great day.